Welcome to Study Loop.
So for the first part of this question, we're trying to find the limiting reagent. So first, we're going to figure out if we use up all of the acetic anhydride, how much aspirin would be produced. And then we would calculate if we used up all of the salicylic acid, how much aspirin would be produced. And from there, we can figure out the limiting reagent and the theoretical yield. So first, let's figure out how much aspirin is produced with 3 mils of acetic anhydride. So in order to compare the amounts of the acetic anhydride to aspirin, we use the molar ratio given to us by the coefficients of the equation. So that means we have to get these into moles. So first, we have to convert these milliliters into grams by using the density, and then we'll convert grams into moles by using the molar mass. So we have 3 milliliters. I'm just going to abbreviate it as AA for, we'll call this AA for acetic anhydride to make it less cluttered. We convert it into grams by taking its density, which is 1.08 grams for every 1 mil. Then we convert grams into moles by taking it times its molar mass, which is 102 grams per mole. So for every 1 mole, we have 102 grams. Then we compare moles by looking at the reaction. We have each compound has a coefficient of 1. So that means that for every 1 mole of, I'll put ASP for aspirin, we have 1 mole of acetic anhydride. And this will tell us how many moles of aspirin are produced if we have 3 mils of acetic anhydride. So milliliters cancel with milliliters, grams cancel with grams, moles will cancel with moles. Type that into your calculator. 3 times 1.08 divided by 102 times 1 is going to be 0.0318 moles of aspirin. Now we're going to do the same thing with our salicylic acid. So we start out with 1.25 grams. We'll call this SA of salicylic acid. We have to convert grams into moles. So we take it times the molar mass of salicylic acid, which is 138 grams per mole. So for every 1 mole, we have 138 grams. Then we look at the equation to look at the molar ratios of the compounds. So we have for every 1 mole of salicylic acid that reacts, we get 1 mole of aspirin. So we get 1 mole of aspirin for every 1 mole salicylic acid. Grams cancel with grams, moles cancel with moles. Take 1.25 divided by 138 times 1. And you should get 0.00906 moles of aspirin. So because the salicylic acid produced the smallest amount of aspirin, the salicylic acid is going to be our limiting reagent. So now that we know our limiting reagent, let's calculate our theoretical yield. So our theoretical yield is how much aspirin would be produced if all of the salicylic acid of our limiting reagent was consumed. So we already calculated that if we had 1.25 grams of salicylic acid, we would have 0.00906 moles of aspirin, but let's convert that into grams. So our theoretical yield, right, is 0.00906 moles of aspirin. But let's go ahead and convert that into grams by taking it times its molar mass. The molar mass of aspirin is 180 grams for every 1 mole. Moles cancel out. Take 0.00906 times 180 you'll get 1.63 grams of aspirin. So this is going to be our theoretical yield. So that is if 100% of it was produced. All of the salicylic acid was consumed. This is the maximum amount of aspirin that we could get if everything went perfectly. So this is our theoretical yield. Now we need to calculate the percent yield. In order to calculate the percent yield, it's equal to the actual yield divided by the theoretical yield times 100. So our percent yield is going to be equal to our actual yield, which is 1.22 grams, divided by our theoretical yield, which is 1.63 grams, times 100. Type that into your calculator, and your percent yield should be 74.8%.